Alright, now the bytecode is loaded onto the memory, so it takes up some space. And in that code, there are const and static variables, which can be accessed globally in time complexity of 1. And the remaining everything is loaded onto stack and heap. So we can understand everything with a diagram. Consider this is a full memory. So the first part will be our bytecode. It will take up some space. The second will be the const and the static variables. These are not loaded, uh, these are loaded separately so that they can be accessed globally. And the other part are the stack and heap. Let us understand what they are. Alright, so stack loads all the variables, functions, and pointers in LIFO manner, that is last in and first out. It is faster access as you can only access the top elements in constant time. This is used to store only a predefined size of data. If we try to store anything in stack which is computed at runtime, then it will throw us an error. So this is what stack is. We'll be understanding stack with examples later on. Now we come on to heap. So heap is larger than stack and is used to store data dynamically. Like arrays in C++ have limited size. And if we want to increase the size of a data structure during runtime, it can be done using only the heap. It has slower access to the elements we can consider a linear memory. Let us understand this using an example using a diagram. So, alright, so consider you have a linear memory. The space from address 2 to 5, that is here to here, is already filled with some data, and you have to store a data of size 5 from address 0. So this whole memory is in heap. So you have to store the data of size 5 from address 0. How will we even store it? So the data first and the second byte goes to 0. So the first byte goes to 0, and then in the second byte you cannot store the byte here because you cannot point it to the other data. What I really mean here is the first byte is filled over here, and in the memory address 1, what happens is the 1 stores a pointer to an empty memory, that is an empty address available. So the empty address available is 5. So it will store a pointer to the memory address 5, and the data there is stored till 9. So it will go on the second byte, the third byte, the fourth byte, and the fifth byte. So the size 5 data is stored perfectly here. Hence you can see that there are multiple memory jumps, which makes it slower than stack. Alright, this is what stack and heap are. Alright, so we'll be understanding how to run a program and how things are loaded into the memory of the code. So consider we have the main function. So everything which is inside the scope of main will be loaded onto the stack. So for the main function, a new stack frame will be created which will store a pointer to the space inside heap, that will be the data which is passed on to the string from function as a parameter, which is this. So the name variable will be stored inside the stack frame, which is here, and the println function, and for the println macro, a new stack frame will be created. I have not created it, so let us create it here. So println, and a pointer will be made here which will be pointing to the println stack frame. Okay, so how the program will execute is, First of all, we'll come across main. The stack frame will be created. We'll come across name. A pointer will be created to the heap. When we come across println, we create the stack frame here. And now as the function is going to end, this println, that I have not told one thing, that is the top stack frame can access the data of the below stack frames. So name variable will be accessible to this println function. So the println can now access the name, so it will print out the and then as this is finished, this will go out of scope and this will be deleted. And now as the main function is completed, the stack frame will also be deleted. And now as the stack is empty, we can conclude that the program is finished. I will be explaining what will happen to this memory. There will be three things which are going to happen based on the language. That, consider if it is C++. If it is C++, then there will be a memory leak. If it is Rust, then the data will be automatically deleted. And if it is Go, then there will be garbage collecting cycles which will also automatically delete the data. We'll be learning about these three techniques in the next topic. All right.